The next part is about the design of the controller. And basically, this is a part in which we put all the knowledge together that we have gathered in the earlier lectures, both in the, you can find it in the homologation program, so in the third year class, and what we did until now in this class. So the active antenna, let's first look upon the active antenna, how we are going to construct it. And I told you we are going to use this configuration. So basically we have a voltage at the input, at the output of the antenna, and the voltage is the electric field times the length of the antenna. This is valued for short rod antennas, of which the length is much smaller than a quarter of the wavelength. The capacitance also depends on the length, so that is also expressed here. So this voltage source and this capacitor, the first capacitor, are part of the antenna itself. Then we have the integrating transimpedance amplifier, the output resistance, the cable, and so we do brute force and the voltage across the load. So the antenna, as I told you, is here, this part. The function is E field to voltage conversion, and the parameter that we use from this is the gain, or the length of the antenna. That is important to know. The next thing is the amplifier. The function is an integrating transimpedance cable driver, you could call it that way, because of the characteristic impedance and because of its integrating frequency characteristic. What are important parameters of the amplifier? Of course, the gain and the output resistance, that is from the ABCD we discussed before. Noise, oops, everything comes here already, I forgot to remove it. The voltage and current drive capability, the mid-band accuracy, the bandwidth, the weak nonlinearity. Then we have the amplifier itself, that is decomposed again in a feedback network. That is only the capacitor. So that sets the accuracy of the transfer. So the capacitance and its accuracy are very important for the accuracy. So they relate to the mid-band accuracy of the amplifier. Then we have a controller or error amplifier. So we call it controller from control theory. So we don't call it an op-amp because an op-amp is a thing and a controller is a function. And we need the function of a controller, and we don't need to put an op-amp there with all the usually characteristic you assign to op-amps. So it can be a single stage or multi-stage amplifier. And of course, important, its equivalent input noise. We will show that it is really directly related to the noise of the amplifier. The voltage and current drive capability, directly related to the voltage and current drive capability of the amplifier. And then we have things that contribute to mid-band accuracy, and that is mid-band loop gain. And the controller gives a contribution to the loop gain because also source and load impedance, as you know from the feedback model we use, can be part of the expression for a loop gain. So one important thing is the contribution of the controller to the loop gain. In a similar way, we can say for the bandwidth, the loop gain pulse product and the contribution to it is an important parameter for setting the bandwidth of the amplifier. And similar exists for this weak nonlinearity. The differential error to loop gain ratio, also explained with a feedback model. I think it is chapter 11 or so in the book. The contribution to that one has a relation to the weak nonlinearity. So you see, we find relations for the design of the controller in relation to performance parameters of the amplifier. Well, of course, we also have the output resistor, and this is just a brute force way of setting the output resistance, so the resistance and the accuracy are important. So now we have discussed the complete decomposition of the system, and we have an idea about the important parameters for all the blocks and all the parts. This is called a functional breakdown, and the error distribution, you could say, okay, I now make error budgets for all the components, is an error breakdown. We are not going in detail about this, but this is basically systems engineering.